Good afternoon.
So let's wait a couple of minutes for the rest to join.
Yes, it would be nice because like 10 minutes ago, our last lesson ended.
Okay, so we can wait 5 minutes. Do you have something else after mine class?
No,
And we can start and finish later.
well, yes, I guess 5 minutes won't make any problems.
So let me start recording. Yeah. Today we will talk about network effects and site heterogeneity. So that firstly, let's consider the price competition of two two-sided platforms. Can you remind me some examples of such such a case?
Does it matter? Are the sites choosing multiple platforms or only one?
No, that doesn't matter. So just competition between two platforms on the same market.
Let's say Uber and Yandex Taxi.
Yeah, that's a nice example. So and then firstly, think that consumers on each of the sites are homogeneous. That means that there is no difference between agents on each site. So then what will be in equilibrium, what you can expect that if they have two platforms and they have competition in prices, and then agents on both sides are identical to each other.
Well, I guess the feature of the uh, equilibrium that it would be like symmetric for the platforms.
Mm. Well, yeah, can be. So, but what does it mean that the agents are identical to each other?
Like that the half of them is going to one platform and another to another, or something more complicated.
No, not complicated, but that if any agent is the same as another agent, so they behave as one agent, so that everyone behave exactly the same as another one, right?
But um, don't we introduce some kind of, well, if we assume that the platforms are alike, don't we introduce some kind of well 50% chance of choosing the platform?
Yeah, exactly. We will, and we will see what happens in that case. So, like, yeah, we can firstly expect that there will be symmetric equilibrium if everything is symmetric, right? Yeah, if some platform can lower the price more than another one, let's say that the platforms are different in costs, so that one platform can make the price lower, then everyone probably will choose the platform with lower price. So then let's consider the situation if each consumer on both sides is different to each other, and let's think about the vertical differentiation so that um, agents are different in quality on both sides. So which example you can think about here? So, will example with Uber and Yandex Taxi work here?
I don't think that the passengers can be like well, we can't assume any kind of measure of quality in the sense of the passengers.
So then for taxi drivers, it's quite easy, right? So that we can think about the level of the car and maybe um, the quality of driver skills, so that you can order business class or you can order some regular taxi cab. But I think for consumers it will work out if you'll assume that they have different income, for example, and some of them can pay more and some of them cannot.
But um, I thought that income is like another variable, and we can't really say that the quality of the passenger is equal to his or her income. Or can we?
So we can, because like it's not something in the model what is like really related to yeah. So by now we are not talking about the model, but so that if a consumer has the possibility to pay more, it's can be less quality or felt like that about it. So yeah, some other examples maybe before we will discuss what will be in equilibrium.
It's just a more complicated model, so it's not for the fact that well, we can't think of the consumers as like one aggregated consumer.
Right. So let me introduce you the job searching platforms, for example, that you can think about the workers with different skills, so that you have a quality of workers on one side, and then you have different jobs on the other side. And they can think that one job can be better than another, right? So what we can expect in equilibrium in that example? Or in previous one, maybe it will be better to think about if you're talking about the cars and uh, the consumers who are willing to pay more or less.
Maybe it will no longer be necessary to be the same for the platforms to be exactly the same to get some users. One platform can target like better consumers and another can target worse.
Great, thank you. Yes, so just we can think that the consumers with higher quality would like to pay more to find the match with the better quality on other side. And those who are not willing to pay more with lower quality, they will um, be able to pay lower price for platform and then match with a lower quality on other side. So then um, let me say it with an example. So firstly, we can think about if you are searching for some taxi, we can think about that maybe someone who is very rich will be able to pay some additional fee to have access to the drivers with high quality or with more premium car used in the service, so that probably the platform can specify on these guys who are able to pay them more to then receive the better quality services, as well as drivers with higher quality cars will be willing to pay more to get these consumers who are able to pay more for them for services. And yeah, so we probably already discussed some examples, but we can see that the main difference in the equilibrium which can happen is that firstly we can think about the situation then all agents behave as one, and then we cannot distinguish the groups of agents on sites. But if we are talking about heterogeneity, then we can think that different platforms can focus on different types of agents and then help better to match one type, and another platform will help to better match another type. So then let's think about some models. So just that was just some thoughts. First, let's assume that we have some utility function, which depends on number of agents on other side, and then price of the platform. So our utility is increasing in number of agents on other side. That is, if I'm searching for taxi and there are more available taxi drivers on other side, it's better for me because I can easily get the taxi, and so it's decreasing in price of the platform, so that if subscription on the platform is lower, then it's better for me. That's kind of obvious. So let's think about that we have two sides. Yeah, before we consider only the model with one side. So now we have two sides that if we are talking about buyers and sellers, then what we are interested in is in a better match. We already discussed it in previous lectures with different examples. And let's start from the situation then buyers are homogeneous, so that we have just the some weight of buyers, and the same for the sellers, so they all behave as one. And we will think that the platforms will charge the subscription fee. So it's like you join the platform, then you pay something. And then what is going on platform? The sellers sells item to buyer, and then the platform will charge some subscription fee from this deal. So if there is match between seller and buyer, then there will be the additional fee to happens for this transaction. Can you actually imagine something like this in the real world example?
I'm not sure, but I guess it's the fee system of Profero. So I guess you need to pay to to become a tutor there, but also you need to pay for every lesson you actually do.
Okay, good. I would provide one more about Apple and App Store. Yeah, maybe you heard about these problems of Apple with fee that they firstly push the developers to use only their app, and all payments supposed to go through their services, so that no one can give the possibility for user to download their application from internal website, so such that every payment goes through the Apple services, and then they subscribe 30%, if I remember correctly. Yeah, so now they make it a bit lower, so it was a huge problem for Apple, and it's law description in discussions right now in US about that, how it's better to do. Yeah. So and then if you buy something in the game, so then Apple receive 30% of the transaction. So you kind of pay this to Apple just to have access to good match with game developers.
I think Profero requires like 20%, and that's the reason why tutors usually, well, they just go into the direct contact with their students, like after the second lesson, because 20% is like too much.
Yeah, that's actually a good comment because if you're talking about such a platforms, then you already have some match, and you build the long-run relationship with tutor and student, then you don't need the platform anymore, right? So then you got the match, then you leave the platform, and you can operate without platform. So then there is no need to contact through the platform anymore. So what the platform would do in that case? So what would be the great idea how to change the strategy for platform? Can you think?
Yes, we actually discussed it on our.
With Andrei?
Yes, well, it was on the well on the slides of one of the teams. So actually, you can reduce the fee. Like if it's the first lesson, you'll take your 20%. But if it's like the second lesson of the tutor and the student, platform could have taken just 10%. And furthermore, like the percentage should have been decreasing, because in this case, well, the percentage could be like too small for the participants to like take some extra actions and make another channel of connection.
Yeah, as well. What is the interest here, so that the students are interested in better match with tutors, so that platform kind of guarantee that the tutors are good with good quality, so that it could be somehow organized. I think that if you provide your lessons exactly through the platform, you increase your quality based on some rating, not just exactly you make the lessons on the platform. So that kind of if platform provides some services with feedbacks based on the lessons which goes through the platform. Because if platforms see that you just you find the students to tutor, then you leave the platform, then the platform just see that you make only one lesson for this student. So that can be signal that you are bad teacher, or maybe you are cheating on the platform, so that you are building your own connections somewhere else. So that kind of these two things which platform dislike. So then if you have only one lesson on the platform and one transaction, you will be in the lower side. So it's like kind of the platform can mark you as a lower quality tutor. Okay, then let's move on, and we will write the model. But let me first introduce the main parts of the model. So we have two platforms, first and second. We are talking about buyers and sellers. And let's say that the utility of joining the platforms is the following. So it's 0 if we are not joining any platform. So, and if we are joining platform I, so then the utility of agent on site G, so G is buyers and sellers, is the following expression. There, it's like that. So that M is subscription fee, which platform I charge from site J, from buyers or sellers. And then we have the number of users on other side. So if you are a buyer, you will care about the sellers on other side. So it doesn't matter for you how much buyers you have on the same side. What is important for you is the number of sellers on other side. And then PI is a transaction fee for match between you and other side. So then we can write the profit of the platform. So the platform charges subscription fee M from both sides, and then there is a transaction fee, which pays each side with weight 1/2. So then the profit will be number of buyers which join the platform multiplied by subscription fee for buyers minus costs to connect the buyer for the platform. Then we have number of sellers on the platform I, and the same subscription fee for sellers minus costs of sellers. And then we have the last part is corresponding to transaction fee between match, so that we assume that every buyer makes a deal with every seller with some parameter lambda, so which can be the probability or whatever that you are matching well and you make transaction. But basically how you think about it, that everyone on one side connected to everyone on other side. Any questions here with formulas?
About profit, could you please explain it again?
So what platform charge from the user is the subscription fee from one side and other side. So then we have a subscription fee for buyers and sellers, and multiplied by number of buyers and sellers, minus cost of connecting exactly one buyer and seller. So this is clean.
Yes, it is.
And then we assume that everyone who connected making some deal with everyone on other side. So that's why we have multiplication here. and then we subscribe from one match P. I is a transaction fee. That's why it goes here.
Transaction fee, is it P or is it
It's
alpha?
P. Now you mean lambda?
Yeah, sorry. And lambda, what is it?
Lambda is just parameter from the utility. We can think
Okay.
about it as a probability that we make in the match with, so that we, if we are connected, so that we make some deal with sellers on the other side.
Okay.
When then we should think about how the things going on, what going on first and what the second. So what will happen? The firstly, as before, the platform choose the prices, so that each price, each platform simultaneously and non-cooperatively decide on prices, which is subscription fees for sites and transaction fee. So then, for both sides, each agent will decide to join the platform 1 or 2 or opposite. And can you tell me what is important for agent to join the platform?
Like, is his utility greater than 0? In this case, not.
No, that's true as well. So, but he choosing between two platforms, what he will be interested in to happen on the platform he will choose.
The more users, the better.
The more users on other side, right?
Yes.
And so he will observe the price. It's already decided, right? So he can observe the price. But then he need to think about the number of users on the other side. So then, as before, the agent will need to build expectations about how their other agent will behave in equilibrium to make a decision to join each platform. Because they do it simultaneously, they don't know how the other already decide. So then they need to build expectation about others. So once again, so if we are talking about homogeneity right now, then all makes the same choice. And what you can expect once again in this platform?
They're similar.
Yes, so they're similar, they make the same choice. And which platform they will join?
Randomly?
But step before. So they observe prices, right? So which platform they will choose?
With the lower price.
Yes, so that then the platform which can make the price lower will steal all the consumers, right? Then what will be with prices in equilibrium?
They should be equal to margin to marginal costs. Like, companies are working into the zero profit.
Right, so then the subscription fee will be equal to costs of joining the platform. We'll go back Yeah, so that this term will be equal to 0. This goes to 0. And what about the transaction fee?
Like 0?
Yes. So since there is no costs to take the transaction, then we can put it to 0. So then in equilibrium, every price for transaction will be 0, and prices for cost will be equals to prices for subscription will be equal to costs. So by now, let's assume that for different platforms, the costs are the same. So that as here, the costs are not differ for different platforms. So then we can say that the prices for subscription will be the same as well, equal to each other. And what we expect in equilibrium, once again, it will be symmetric equilibrium, as was mentioned, if we have everything symmetric in the model, then the agents will join one platform with probability 1/2 and another platform with probability 1/2. But will this equilibrium be stable?
Yes, it will be.
So then let's consider situation. Yeah, okay, indeed. Everyone chooses the platform with probability 1/2. So they have a half of the consumers on one platform and half of the consumers of another platform. The prices are the same. What if one consumer moves from one platform to another? Just deviate from equilibrium.
Nothing happens. Others won't follow him. No, they will follow him because now the utility from another platform is larger.
Yeah, exactly. So this equilibrium will be not stable. And then what happens? So like if we move from the equilibrium, so we move one agent to another platform, and then the rest will go and move with him as well. So then what will be the result in the market?
Only one platform will remain.
Yeah, only one platform will survive, and we will observe the monopolization of the market. So we start from the competition between two platforms, and then we end up with one monopoly platform. So my question to you, what does it remind you? We have some. Well, okay, it's a competition, price competition for homogeneous good, and the results are similar to the usual Bertrand competition model with homogeneous good. So then the firm which put the lower price gets everything, then we goes to zero profit in equilibrium. Yeah, that, some of this was already mentioned. Yeah, but here they can observe some differences as well, that on the two-sided markets and platforms, we have network effects, and that's why the equilibrium, which is symmetric, cannot happen here. It's unstable and leads to monopolization. Right, so in Bertrand model, you can say that, yeah, with probability 1/2, then choose the two films which produce some good, and then the slow deviation of one agent to another will not make this effect of that everyone will join to another platform and end up with monopolization of the market. So, but that was for the homogeneity, and now let's move to heterogeneous agents on the sides. So let's think about the similar settings, but with type of agents. So that the buyers and sellers have the quality theta, and we will use our example with companies and job candidates. That worker can come to the platform and search for the company on the other side. And
excuse me, and are the platforms heterogeneous as well or not?
no, the platforms just set the subscription fee and provide the same, so that they match the
Okay.
the agents. And let's assume that candidate which subscribed to the platform is randomly matched with the company which is presented on the platform. Then my question to you, what is the difference here for job searcher agent? So what is the difference for job candidate here compared to the previous case with buyers and sellers?
It won't be just like 50-50.
Don't think about so complicated stuff. So notice that the candidate is randomly matched with company which is available on the platform.
Do they have the option to disagree with the match if they see, for example, some kind of blocking pair?
No, they just randomly match with one and have to go to this job, so that if you join the platform randomly choose for you one of the jobs on the platform, and then you match with exactly this randomly chosen company.
Well, maybe the quality of the other side matters, and it wasn't like that in the previous model.
Right, and does number matters?
Maybe it matters less.
So now I don't care about the number of the companies on the other side. I'm more curious about the quality, right?
The quality of the worst company present, maybe.
Well, since I'm randomly connected, I worry about the average quality. Then I choose between platforms. Yeah, so that the candidate is not caring now about the number of the platforms. Oh, sorry, number of the companies on the other side. He cares about the quality of the worker. And for for company works the same. If they're searching for better match, they are caring not about the number of the workers, but about the quality, average quality of the workers on exact platform. So then we have not network effects such that the number increase our utility, but sorting effects plays a crucial role here in the model. So then let's see how it works in the model. So again, we have two platforms, two client sides. Let's denote them buyers and sellers once again. So they have total mass of buyers and same for sellers, and they have different types. Let's say that they are randomly drawn from uniform distribution from A to B. And again, our utility now slightly changed, not slightly, but so the structure is the same. If I'm not joining the platforms at all, I receive 0. If I join the platform, I have my own quality, and it's multiplied by the average quality on the other side. So J now is the sides, buyers and sellers, and if I'm a buyer, I'm caring about the average quality on the platform for sellers. Minus J means sellers. No, minus J means the other subscript. Oh. And let's me write it on the noteboard. So I will now choose another slide because we will rewrite this later on as well. But firstly, we need to decide on what platform choose and the timing. So the platform chooses the subscription fee, and now they're thinking that there will be 0 marginal cost to connect any buyer or seller. Then there is no transaction fee as well, since it's not in our utility, if you remember. Then the timing is following so that the platform 1 chooses M1, and then platform 2 chooses subscription fee, and then each buyers decide to join platform 1 or platform 2. Can you mention some difference here compared to the previous model?
Didn't platform just choose their subscription fee like at once, simultaneously?
Yes, that's one difference. So that the firstly one chooses, and then another one. So what you can expect? So we can expect that choice of the second platform will depend on the price chosen by the first one, right?
Well, it's more like then the choice of the first one will depend on the expectation of choice on the second one, which depends on the choice of the first one.
Yes, exactly. So we will solve it as a backward induction, so that we will solve it as firstly the last step, assuming that the price are known. Then the second platform chooses the price, assuming that the first price are known, and they already know how the agents will behave. Some other differences here. I think I have something else here on the slide. Yeah, our goal is to think about the equilibrium then both platforms exist. So we already have the model which can describe us the situation. Then the market moves to monopolization that can describe the situation, then only one platform exists. But now we are interested in the situation then both platforms operate on the market. So then let me stop sharing the slides. So now you'll see me from different perspective. Yeah, you can see the board. Great. So firstly, we have two platforms. Let me write lecture 4. So we have two platforms, first one and second. One more second. And they have two types of agents. So they have buyers and sellers. And they have different type teeter for every type of agent, and they are distributed uniformly on interval AB. So then utility of the agent J is the 0 of we are not joining the market, the platform teeter, my own teeter, and I know it, right? Because I know about my teeter, but I don't know about the teeters on another side. So I have to take the expectation of the types on other side among those who join the platform. The platforms are denoted by I. So that's our utility. And then we remember, firstly, the first platform choose the price, then second one, and then our decision. So, okay, join or not. So one more difference here. Maybe you haven't noticed, but in previous model we have different fees for agents on both sides, so that on different sides, that buyers and sellers can be charged with different price, but here they are talking about that the fee is the same because we don't have here J for prices, so it will be the same. So then, okay, it's the last one. Then 1 second. Yes. Let's move to the. Let's think about the agents. So let's think that we know that M1 and M2 are already decided. So what is the agent decision to join one platform and what we did the last time with one-side platform? Which agent is the crucial one in the analysis?
The one who is indifferent between joining and not.
Okay, so let's think about that. We have indifferent agent, for example, buyer. So what we can tell about our distribution of agents. So this agent is indifferent between platforms. Can we say something about the other?
Maybe we can, but well, I will assume that I don't know how to treat this mathematical expectation. It depends on the type as well, right?
Right. Not on your type, but on type of other side, right?
Yes, but like it's not connected here.
So then buyers decide on joining the platform, which platform to join. They can think about the other side somehow. Yeah, as we do, we are talking about the Nash equilibrium because they simultaneously decide they're expecting something which is holds in equilibrium. So, but your expectation about the other side will be the same for every buyer, right? Because what's going on in equilibrium is going on for everyone. So then our expectations about the other side will be the same for every buyer.
Not exactly. Like the condition of those expectations will be the same for every buyer, but it's like, do you know this link between like theta j and some I don't know equilibrium for each j?
Okay, we have J here, for example, the buyers. We have the same situation for sellers, right? So that they will be A, B, and theta sellers, right? So there will be the agent who is indifferent for sellers. So now we can they can think about some expectations right here. So then we kind of specify this buyer. You can say that every buyer can think that a seller who is above the indifferent one will join, for example, orange platform, and who is before will join the violet platform, right? Then let me say one more thing here. Would you agree with that?
Yes, okay, but how does it connect with the theta of bias?
So because buyers make a decision based on expectation about sellers, right? So you have to compare your utility of joining one platform to another. When let's firstly specify which site will join which platform, and let me assume that you remember that we are building the equilibrium, then both platforms exist. So then probably if the platform will choose the same subscription fee, that will be kind of the same behavior, and then the agents will choose just the platform with larger numbers. So intuitively, we need to choose the equilibrium. Then prices are different. So let me say that firstly was chosen the lower price for platform 1, and then platform 2 choose the higher price. Yes, because then they pick the same price, then the agents will pick just one platform, and then we will have the monopolization again. Is it clear?
Like, if they choose the same price, we just return to the previous point.
Yeah, so because there's no difference between platform, then high number of so it's tricky, but we will return back to monopolization. Yeah, so let's assume that the platform 1 chooses a lower price. So then those who has higher types, yeah, so we know that we have the situation. Then we are talking about multiplication of our type to what we have matched with is our utility. So if we have higher type, then we got higher utility. Then we are kind of willing to pay for this match more. So then we can say that the platform, the orange one, will be the second one, and the violet will be the lower one. So the lower types will join the first platform, the second platform will serve the higher types. So then, once again, they are talking about the indifferent buyer. So what he expects to have if joining platform 1 is, firstly, it's his type indifferent one. But then, what we need to take?
Like, somehow model this expectation.
So we know that those who join the same platform, so we are talking about the indifferent guy. So he chooses between platform 1 and 2. If we are talking about the utility from joining the first platform, who will join the first platform is the guys in violet side, right? So those from 1 to theta s indifferent. So how I can write the expectation here of joining the first platform?
Theta s hat minus a.
A bit different, so it will be plus a over 2, right? But yeah, you thought correctly, so that we take this average from this interval, and then the platform 1 will subscribe fee 1 from us. And what is the utility from joining the second platform? again, they have our theta. Well, we will have the same, right? So we will have theta s plus b over 2 minus m2. So that's for
Why?
indifferent.
Why?
Why what?
Why is it like theta plus a divided by 2 and not as Dasha have mentioned, like theta s minus a?
You need to take average from here, right? You have uniform distribution, and what is average is exactly in between. And what is in between is a plus theta s over 2.
Ah, yes, okay.
So that's the equation of indifferent guy. But now can I ask you if there are any differences between sellers and buyers here? So what do we know about sellers and buyers? That they have the same utility, they distributed on the same interval, they are distributed uniformly both, they just have different notation, right?
So there shouldn't be any difference except for theta's indexes.
Alright, so then we can say that in equilibrium, the indifferent buyer will be equal to indifferent sellers, and let's just say that this indifferent agent. So then we can rewrite our equation as theta hat plus a over 2 minus m1 equals to theta hat plus b over 2. Right, and let's solve it according to theta. Let me do it a bit fast. So here they have half theta plus b minus theta minus a. No, the opposite. Right, so then we have yeah, and you can notice that b minus a over 2, it's exactly the guy who's in between. So that but now we know the indifferent guy, and how the indifferent agent on both sides will depend on the prices. What is the next question? So now we know how the agents behave. So then if we take the interval from A to B, we have theta indifferent, which we know already. So that we know that those who from theta hat to B joins the platform 2, and those who from A to theta joins to platform 1. So with agents, we are done. What was the previous step?
Subscription fees.
Yes, and we know who joins platform and who not. And then the second question is how to second platform choose the price. So the second is M2, and we know that it's already chosen M1. So what is the profit of the second platform which we want to maximize? We're maximizing choosing M2.
We should maximize the profit.
Mm-hmm.
We had it on our slide, I guess.
So then you have the subscription fee and then number of those who join the platform 2. And who joined the platform 2 is B minus theta, right?
And about transaction fee?
We don't have it in this.
Okay.
In this model, we don't have the transaction fee, and our marginal costs are 0. So that we have just this. So then we can plug here our formula for theta. We know that theta is 2m2 minus m1 over b minus a. Right? And then we need to take the first order condition with respect to price. So then let me rewrite the expression here. So we have M2. So then now they need to have firstly B. So we have B minus so what is the first order condition? That's B. Then we have this and then we have minus M2. It will be minus equals to 0. Yeah, I think I haven't done a mistake. Well, what we have here, we have kind of the same, so that this is 4m2 b minus a on one side, and then we have b plus 2m1 over b minus a. Am I right?
What is the first symbol of the...
4.
Okay.
Because they have 2 here and then 2 here.
Yeah, I see. Okay.
So we have 4 m2 equals to b minus a plus 2m1. Or we can say that m2 equals to well, let me check myself. Yeah, I'm right. So, and this is the function m2 of m1. So that's the answer for the second question, how the platform 2 choose the price based on the choice of price of platform 1, right? Let me calculate the indifferent theta now and the choice of, and because before it was depend on both prices m1 and m2, but now m2 is a function of m1, so then we can rewrite it. So it was 2 m2 minus m1 over b minus a. So now I need to put in this expression. So it will be 2 is b minus a over 4. And then I have plus m1 over 2 and then minus m1. So it will be minus m1 over 2 divided by b minus a. Multiplying by 2 and divided by b minus a, what we have b over 2, and then we have minus m1 over b minus a. So that's our theta hat based on MA. So then what is the last question we haven't answered yet?
M1.
Yeah, so the last question is how the platform 1 choosing M1. So, and help me please to write the profit maximization problem.
Shouldn't it be just M1 multiplied by theta minus A?
So those who join our platform are from A to theta, right?
Yes.
So that's theta minus A, correct. Yeah, you say theta minus A or A minus theta? I forgot.
Theta minus A.
Yeah, okay, and then we need plug in our expression for theta. So that will be maximization of m1 b over 2 minus m1 b minus a minus a. Let's take first order conditions to find optimal m1. So it's again expression inside. And then minus m equals to 0. So what is this? So we have 2m1 b minus a equals to b over 2 minus a. It looks like that. So then M1 is B minus A over 2 multiplied by B over 2 minus A. So they got the expression for price of first platform. And then let me calculate the indifferent agent. Once again, remember it was B over 2 minus M over B minus A. Yes, yes. So then it put inside M1. Can cross this. And what we got, B over 2 minus B over 4 plus A over 2. So it's B over 4 plus A over 2. That's our resulted theta. And then last question to you. What do they need to satisfy to have two platforms operating on the market?
That the profit of the companies, well, of the platforms should be greater than zero.
Yeah, but it's something positive anyway, right? No, but what I can say about theta resulted in equilibrium?
That it's between A and B.
Yes, it's supposed to be between A and B, exactly. So that if you have A and B, and they have a different agent theta head here, so if it goes to B, like everyone joins to platform 1. If it goes to A, then everyone joins to platform B, platform 2. So then we need to satisfy two inequalities, that beta over 4 plus A over 2 greater than A, and the same lower than B. So then we have beta over 4 greater than A over 2, and A over 2 lower than 3 beta over 4. Yeah, it's B greater than 2A and 3B greater than 2A. All right, so then first is satisfied, the second is already satisfied. So what we end up is that B is supposed to be greater than 2A. And what does it mean?
It means that, well, the types should be relatively distinct.
Exactly. So then we have here 2A, and then B is supposed to be somewhere on the right from here. So that we have distributed agents quite spreadly, so that we have different types, so that the agents are really differ from each other, so that the necessary condition for two platforms coexists. So such that one platform can focus on one types and another platform can focus on other types. Then there can be the situation that two platforms coexist on the market. Any questions?
Yes, actually, at the beginning we said that total masses of both types were 1 and that they are uniformly distributed. So it seems that, I don't know. Well, I thought that mass is equal to 1 means that the length of that interval is 1.
No. The mass of 1 means that your integral from, so let me choose. So your integral from A to B of PDF of distribution for agent equals to 1. So that it could be the case that that you have such distribution, and then if you're talking about the interval length of 1, so if this is 1, so then you will have another distribution which will gives you the same total mass of agent.
Okay, and also we assumed somewhere that the second firm sets a higher price than the first firm. And well,
Yes.
does it matter? Because I think that there will be some different signs somewhere in the derivatives and such. But
yes.
Maybe it would be symmetric, but I'm not sure.
So what we need is just to be clear here. Yeah, we can decide the opposite, that the first one choose the higher price. It doesn't matter. We will just end up with this term will be negative, not positive, and then yeah, it will be the same, but you note the platform 2 as 1 and 1 as 2, and it will be the same. That's just for simple analysis to think that someone decided on higher price. What was important is that the price are different.
Okay, I mean there isn't a rule that the first mover sets a lower price, for example.
No, it was our assumption. If you will make it higher, so then the situation will repeat, but your derivation will have the another sign.
Okay, so there isn't like an economic reasoning behind it.
No, there is no. So if first one will choose the higher price, then the second will choose the lower in this model.
Okay.
Then I want to repeat that we have another exercise session on Thursday instead of Friday. The time is the same, and I expect that both groups will join at the same time at 1 p.m. Is it fine for you?
Yes, it is.
So Nick is from the second group, if I remember correctly.
Yes.
And from the first group, someone here?
Well, we also have no classes on Thursday.
Great.
So technically it should be possible for the group.
Okay, then I expect you will join together. But I will write you maybe once again tomorrow. Please join together. Okay, so that was about the heterogeneity, and I think that will be the main topic for midterm. So I will send you the notes from the class, so you can go through it by yourself, and I will send you the slides. Okay, let me stop recording.
And when will the midterm be?
Probably next week, since the covered it's on the lecture, and we will discuss this on exercisation. So then next week we will have midterm, so we will be able to solve the problems.
Will it be like open book or closed book?
I will send you the details like before, so you will know.
Okay.
And will there be like a trial midterm or something?
No, really. So you can focus on the problems from exercisations. So you shouldn't expect something harder than we discussed in exercisation.
Okay.
Yeah, but I think it will be crucial. One will be this Thursday, so and because we will discuss this model with two platforms and competition and heterogeneity of the agents.
We just did it, no?
So I can let me
Two,
check what is there in exercisation.
like two platforms and heterogeneity of the agents. Maybe
So that's hmm?
no.
Yeah, we will solve the problem with some additional questions, so you will be able to think what kind of a problem can be on the midterm.
Okay.
Because you can assume different utilities, for example, or a different price for the platforms, for the sides of the platforms. Okay, then that's all for today. I will send you materials probably today or tomorrow, and see you on Thursday.
Thank you. Goodbye.
Bye.